Hey there, what's up guys? In this video, we're going to be having a look at derivatives from first principles. Let's have a look at our first example. If you have a function f of x, which is equal to x squared, and you need to find the derivative for this function. First, we need to recall what is the derivative function. The derivative is the gradient, and we calculate that by saying the limit as h approaches 0 for f of x plus h minus f of x divided by h. So there's an f of x plus h and there's an f of x, which we already were given. F of x is equal to x squared. We now just need to find what is the function of f of x plus h. Now the function of f of x plus h is simply the function of f of x, but if you substitute x with x plus h. Now let's simplify this. We can get x squared plus 2xh plus h squared. And this function that you get over here, this is what we're going to substitute for f of x plus h. Now, by straight substitution, we'll substitute the f of x plus h with the function we just calculated. It was x squared plus 2xh plus h squared. Then we're subtracting that from the original function, which was x squared. Okay, notice that this x squared will cancel with the original function's x squared, and you'll be left with these terms. Each of these terms has an h. So let's write that down. We have 2xh plus h squared divided by h. We can factor out h as a common factor. Notice you'll be left with 2x plus h, and this is being also divided by h. The h on top will cancel with the h at the bottom, and you are left with 2x plus h. So to continue here on top, we have the limit as h approaches 0 for 2x plus h. Now, this is the point where you want to substitute h with 0. And the moment you substitute h with 0, you do not have to write this anymore, because h has finally reached 0. And therefore, the derivative of f of x is 2x. So to summarize, when we had f of x equal to x squared, the derivative of this function was 2x, meaning the gradient of that function is 2x. Let's have a look at a second example. If you have f of x equal to 5x minus x squared, and your goal is to find the derivative of f of x. Okay, again we'll start at the same spot where we first define the function of f of x plus h. And we do this by simply substituting x with an x plus h. Now to simplify this, we're going to distribute the 5 inside the bracket and also square this bracket. That leaves us with 5x plus 5h minus x squared minus 2xh minus h squared. That's also by multiplying this negative inside after we've squared this bracket. Now you'll have to substitute these functions into the formula, the limit as h approaches 0 for f of x plus h minus f of x all divided by h. I want you to notice now that when you take the f of x plus h function and you minus that from the f of x function, all the terms of the f of x function will cancel out with some of the terms of the new f of x plus h function, because we are minusing them. In this instance, you can see the 5x from the f of x plus h function, once you minus f of x, will cancel with the 5x of the f of x function. And also the negative x squared of the f of x plus h function will cancel with the negative x squared from the f of x function. And what you are left with is again all these terms that has an h. So it's the 5h, the minus 2xh, minus the h squared. That's what we're going to write down for our numerator. So, continuing with the limit as h approaches 0, make sure you always keep writing this. We'll say 5h minus 2xh minus h squared all divided by h. Again, it's important once you have all these terms within h to factor out h as a common factor. That leaves us with 5 minus 2x minus h divided by h. Again, notice how these h's will cancel, and you'll be left with the 5 minus 2x minus h. Again, this is the point you want to substitute h with 0, and so we are left with 5 minus 2x. Again, notice here when we substituted h with 0, we didn't continue to write the limit as h approaches 0 for the last lines, because we eventually substituted h with 0. If we can perhaps just look at a third and final example. If you are given a function fx equal to x to the power of 3, and your job is to find the derivative, let's start out by finding the function of f of x plus h. We are substituting x with x plus h. All other parts of the formula remain the same, so if you have a cube here, we also have a cube. Right, so x plus h cubed is x cubed plus 3x squared h plus 3xh squared plus h cubed. Now remember, f of x, the x cubed, will cancel out with part of the equation of f of x plus h. So if we remember our derivative formula, it's the limit as h approaches 0, where we take this function of f of x plus h and we subtract f of x, the original function. That means that the x cubed will cancel out with the x cubed, and all you are left with are these terms that all have an h. So that's what we're going to write here as our numerator after subtracting these two functions. Now to continue from there, let's substitute our numerator. So we have 3x squared h plus 3xh squared plus h cubed. Notice all the terms has an h in it. Now we're going to remove h as a common factor. That leaves us with 3x squared plus 3xh plus h squared. The h on top will cancel with the h at the bottom, and we are left with 3x squared plus 3xh plus h squared. Now substitute h with 0, and at this stage you don't have to write the limit as h approaches 0 anymore. That part falls away. Also, multiplying something by 0 is 0, so you are only left with 3x squared, and that's our answer. Again, in summary, we started with a function that was x to the power of 3, and we found the derivative of this function to be 3x squared.